Okay, we're going to summarize most of the work from this unit. We're looking at optimization problems. The goal in an optimization problem is to find the best shape given certain conditions, and that's what we mean by optimize. In fencing problems, we want the largest possible area with the smallest amount of fencing. In other words, largest area with the smallest perimeter. We're going to start with an example. A farmer has 12 sections of fencing, each 1 meter long. He wants to make the largest possible rectangular pen for his dog using the fencing. What dimensions should maximize the area? Now, if we look at this rectangle, you add all the sides to get the perimeter. So the perimeter is 2 times the length plus 2 times the width. Now, if we divide all the perimeter by 2, 2L by 2, and 2W by 2, we get the perimeter divided by 2 is equal to the length plus the width. Now, since there's 12 sections of fencing, each 1 meter long, the perimeter is 12 meters. And if we divide that by 2, we get 6. So anytime you get a perimeter problem, for the most part, you're dividing the perimeter by 2 to get the length plus the width equal to 6 in this case. Now they give us a table where they're telling us the different type of pens they're making for the dog. Now when we all in the table we're going to write 12 for the perimeter, but we're going to divide that by 2 to get 6. So 1 plus 5 gives me 6. This is how we fill out the table. 2 plus 4 gives me 6. 3 plus 3 gives me 6. So in other words, you take your 6 and you minus 1. That's on your rough work to fill out the numbers in the table. Area equals length times width. So 5 times 1 gives me 5. 4 times 2 gives me 8. 3 times 3 gives me 9. 4 times 2 gives me 8. And 5 times 1 gives me 5. That's my rough work, so I'm just erasing it because I'm not supposed to hand that in. So what I need to know is where's my largest area? My largest area is 9. And my length is 3 meters, my width is 3 meters, my length is 3 meters when I get 9. So your conclusion that you should draw, most of the times they'll ask you to draw sometimes they ask you to draw a graph, and you're usually graphing the width with the area to find what's the largest possible area for this unit. But again, what I'm looking at is what gives the students the most trouble when they're doing this. And what gives the students the most trouble is filling out the table. So the dimensions, meaning what's the length and what's the width, to give you the largest possible area. How you write it, 3 meters by 3 meters. Because the unit is meters in both cases. And 3 is the width, 3 is the length. 3 meters by 3 meters means 3 times the length, 3 times the width. Or I should say 3 meters is the length, 3 meters is the width. What does that mean? That means all the sides are of equal length. And if I drew this nicely, that would be a square shape. Now, generally, the rule is if the perimeter is given and you want the best possible area for a rectangle, you should get a square shape. And your length, your width would be equal to your length, which should be the perimeter divided by 4. And this is if you're doing a multiple choice question. You get a perimeter and they ask you what dimensions will give you the best area. You just divide the perimeter by 4, and this is provided the perimeter can be split into sections, because if you had a value like 18, 18 divided by 4 is 4.5. This fence was a 1 meter flat. So if that's the case, if you can't split this into parts, then the perimeter divided by 4 might not work. And this only works if you can split the 1 meter sections into half a section, quarter section, things like that. In this case, it worked very well because 12 could be divided by 4 to give you 3. And I hope this helps with this part of the unit.